Are you a person who thought, why is models consistently improving their performance, or the organization are releasing models which are increasing in its performance, be it Llama 3 to Llama 3.1, Gemma to Gemma 2, or Mistral to Mistral Instruct V1, V2, V3 and so on and so forth, with the architecture remaining the same always? How is it even possible? Yes, data is there, but it shouldn't be all data, right? If you have all these kind of questions, then this video is your answer, because good on Meta and Mark Zuckerberg to release a detailed technical report on the working of Llama 3 as well as how they created Llama 3, where they have said about their training pipeline, their dataset collection, their dataset processing procedures, how they made the training infrastructure, and also they have said about each and every component which was involved in their training process. In this video, we are going to see in detail about those, so that you will also be able to understand, and probably one of you might build an LLM by yourself following the procedure which has been said by Mark Zuckerberg. Let's start with an overview. And by the way, this video is kind of your summary of the paper. Alright, as an overview, this architecture is same as Llama 3 and its predecessor. I'm saying about Llama 3.1. Llama 3.1 is same as its predecessors. By the way, here when I say predecessor, it is not just Llama 3. It is even like Mistral, your Phi 3 and so on and so forth. Everyone followed the same architecture, and you will understand why it is. Okay, and then your training, for that to become very stable, they have avoided MOE, because with MOE, when you introduce sparsity in the picture, right, it will disrupt the stability to some extent, and they wanted to avoid that. So even the 405 billion parameter model is a dense model. Okay, so there are positives and negatives in those being a dense model, but yeah, let me have my conclusion at the end about what are my thoughts on this paper, what could have been better, and what is very surprising in this paper. The most important aspect in this paper, according to me, would be this one: followed a multi-stage training procedure. They followed a multi-stage pre-training, and then followed by that a post-training procedure which involves a loop over SFT, rejection sampling, and DPO processes involved in it. If you are thinking, yes, there are lots of companies now who are working for vision and audio, Meta has said yes, we are also going to start that, and that is why they are starting with developing multi-model adapters, and there are some surprises in there. Please stay till the end to know what are the surprises which Llama, or indirectly Meta, has for us. First, let's answer the big question. What is there in the model architecture? Is there something different, or how is it? Let's start with that. So architecturally, Llama is as same as the previous one. Okay, even Mistral follows the same architecture, with group query attention having 8 key value heads. Again, see, when I'm saying about architecture, it is not same. I shouldn't use the word same. I can use the word similar, okay? Because the dimensions obviously change for you. But, the components doesn't change. For example, attention is group query attention. But here they are using 8 key value heads. Probably another one can use 4, another one can use 32. That depends on them, okay? And for vocabulary size, they have used a tick token encoder, which will provide 100k tokens. And then they have also used 28k additional tokens for multilingual, being the model as a multilingual model. Okay, so totally 128k vocabulary size. And there is a small change, like I said. With attention mask, they have created an attention mask to prevent attention between documents within the same sequence itself, so that in long context training it has been very helpful, is what apparently has been turned out in their research. Hopefully, even if you work with long context models, this can be useful for you. As far as the architecture information is concerned, here you have your information. So these are the parameters and these are the model. So let me read it out and explain some things there. So layers 32, 80, 126. So what is this layer? Each layer will have your masked multi-head attention, and then your feed forward, and then your projection. Everything will be there. Okay, so this will be one layer, and those will be replicated for 32 times. Okay, so mostly it is just attention and then your feed forward. Okay, these will be replicated 32 times, and then finally a projection layer will be added there, so that from the embedding dimension it will be projected to tokens of your vocabulary. But with the case of 70 billion, it is 80 layers, and 405 billion, it is 126 layers. That is pretty huge, right? But here you can see, even when we increase around 50 layers, it is just going around 8x, okay? But when you add around 40 layers here, or apparently like around 46, this is also around 46, okay? It is going around, how much? 70 times 6, approximately 6 times, okay? But here it is not the case, right? Because the embedding dimension also come into the picture. The embedding dimension is 4096 in the case of 8 billion, 8192 in case of 70 billion, and 16384 in case of 405 billion. Larger the embedding dimension, better the performance will be, okay? And similarly, feed forward dimension also will be the same. There is a pattern here, you can see it is doubled up here, same here also it will be double. 14336, 28672, and then 53248. Yeah, so I hope you get that. The attention hits, number of hits is 32 in case of 8 billion, 64 for 70, and 405 it is 128 layers. But the key value hits remains the same, 888, because group query attention came for a reason that, when you compute across 32 heads, right, it will take a lot of computation for you. So they wanted to reduce, and they found that with limited number of heads itself for key value, you'll be able to find your, token for which you want to attend, and also it will give near good performance what it will happen with even full number of heads. So what they did was, okay, I'll just apply that logic here. I'm not going to double it, okay? I'll just keep always the heads to be 8, okay? So here it is 888. The peak learning rate is the learning rate in which you start your training with. That is the max learning rate, and it will go on reducing as the training goes by. So with 8 billion, it has been started at 3 into 10 power minus 4, which is 3 minus 4. And with 70 billion, it is 1.5 e minus 4. And with 405 billion, it is 8 e minus 5. As you can see here, the learning rate decreases with the model size being increased. For activation function, they are using a glue activation function. Okay, this is a glue activation function family. In that, they are using swiglue. There is another function called jglue. I guess jglue is used in GPT-4 if I'm not wrong. But swiglue is also very commonly used. Even with Llama, I guess swiglue is being used. So the vocabulary size here is 128k, and for positional embeddings, they are using rotary positional embeddings, which is shortly known as RO, which is renowned for context extension, which is gonna extend your context approximately to 16 times. It can scale up, okay? And the main parameter there is frequency, which is 500k, is what they have used. Now, you know your architecture, okay? Let's start with the pre-training, which is the first step for training any model, right? And don't worry, I'll also finally give you a walkthrough of the paper because it is 92 pages. I didn't want to bore you. That's why I prepared the slides, okay? So if you are like this content, please hit the like button, share with your friends. Only a small percentage of viewers who are watching this video right now has subscribed to the channel. Please hit the subscribe button. I'm trying to hit 10k subscribers within next 2 to 3 months, and if you hit the subscribe button, it will be very helpful. It is free for you. You can unsubscribe whenever you want if you don't like the content. Now, we as developers, we tend to use usually common data like, for example, FineWeb or your C4 and so on and so forth. That is very common. But what is the disadvantage with that? See, when you say a dataset which is already available, it means the timestamp of it will be even more before that. For example, C4, if it is updated till 2021, its knowledge is only till 2021. Okay, you can't provide a knowledge after that. So what Llama did is, or I don't want to call it meta, Llama itself sounds kind of an organization to me now. Sorry if I'm calling it as Llama. If I call it as just Llama as a company, it means I'm referring to Meta. Okay, so what Meta did was, okay, let me crawl the web data at real time, and if I crawl it in real time, there are some challenges like if there is a structure dependent data, be it math, code, your table data, it will fail. When you go give it a sequence, there is no purpose to write a crawler. You can just use beautiful soup and then use it. So what they did was they created a custom HTML parser so that you can crawl the web data, and also you will be able to maintain the structure for math and code. Okay, unfortunately they didn't give the code for custom HTML parser. If it had been given, I would have showed in this video itself, and if at some point of time they give the code, I'll also release that as a video in our channel itself. Deduplication. Now, deduplication is a step in which you will remove similar contents or same content, okay, which is referring to be removing the duplicates. So for this, they have performed it into 3 levels: URL level, document level, and line level. Okay, and they have used n-gram ratio method to remove redundant contents which are present in the document, and to filter out documents which has high outliers, they have used a method known as token distribution KL divergence. Llama 3 is a multilingual model, and when you use a multilingual model, it is very important that you train the model with almost similar composition for other language other than English. Okay, so for that you need to first identify what language it is, because they are crawling it in real time in web data. If it is provided with metadata that this is the language, then well and good, but if it is not, you need to classify it. Okay, so for that they have used fast text, which has the capability to classify into 176 language documents. Okay, now that their processings are completed, they created a data with a ratio of 50% general knowledge data, 25% math and reasoning data, 17% code, and 8% multilingual data. So the sample of multilingual data is very less, so you can't expect a lot of performance out of it, but it has tremendous knowledge in common human knowledge, and it can do various complex mathematics, okay, and also code, because this itself almost accounts half to the data in which it was trained. So that is a pretty good composition. Now you'll wonder, okay, Vasant, you said about the data, that is fine. So what about the training? The pre-training is completed now, because see, the task is going to be the same for every LLM. Okay, it is just to find the next word. Okay, that is basically the task for any LLM. But if every LLM is going to be following the same training procedure and the architecture is also same, what is it that differs with some organization giving better models than others? One thing is, similarly, like I said, when you crawl web data at real time, it will be more aligned to real benchmarks which are coming up, and that has been accounted for already. But it is not that always your LLM will give the best output at the first time, right? You see, we also learn by mistakes. So LLM also will be learning by mistakes, right? So we should give the opportunity for it to learn by mistakes, and that is why they followed a loop training procedure. So the loop training procedure comes into the picture when it comes to fine tuning. But with pre-training itself, the training procedure is step by step or stage by stage, because like, humans, again, we can compare it to humans. When you're a kid, you will be given word to write. As you grow up, you'll write sentences. As you grow up, you'll write paragraphs and then essays and then blogs and so on and so forth. The complexity increases over time. Okay, your class learning is formulated in such a way that you are not overloaded with information to do, because if you do that, your language knowledge will go down, right? You'll be focused on filling the pages or content rather than focusing on having the correct grammar while you're writing. So for that, what they did was they trained this model on 6 stages to provide a context length of 128K. Okay, so this training procedure reveals about the largest model, which is 405 billion parameter model, that has been trained on 15.6 trillion tokens, which is initially trained on 8K context length data, but gradually the context length was increased in 6 stages to 128K. Okay, you can just assume it as okay, kindergarten, and then your primary schooling, middle school, high school, higher secondary, and then your real life. Okay, these kind of 6 stages. Similarly, 6 stages were given to LLM as well. The initial setup was in such a way that the sequence length was 4096 for it to generate. Okay, and in one batch 4 million tokens will be processed. Just remember this, guys, while pre-training the number of tokens matters, not the number of samples. Okay, the number of samples doesn't matter here, only the number of tokens matters here. Okay, and then in the next stage what happened was they doubled it to 8 million tokens per batch size and 8192 for sequence length, with the time being once 252 million tokens were trained. So once 2.87 trillion tokens were trained, 16 million was the context length. 16 million tokens per batch size was the parameter, with sequence length approximately being 16,000. This was going on for 5 stages. Okay, so apparently they would have stopped it at around 32k at some point of time. Okay, but their aim was to go for 128k. So finally they added the 6th stage, which is a long context pre-training stage, where they trained it for 800 billion tokens as a final stage. And they have said that following this stage by stage approach is very stable in nature, and I agree, because like I said, as humans even, you'll be going step by step, baby steps, and then you'll go for larger things, right? So similar thing has been followed here, and huge respect for the persons who have discovered this, and very much huge respect to Meta and Mark Zuckerberg to release this as an information, because there are organizations who might not follow this kind of a pre-training procedure, but now it helps for everyone. But like I said, it doesn't stop with pre-training. Yeah, it goes beyond that. And here, like I said, they are going to follow a loop procedure, which is given here. First, a reward model is trained on a set of preference data. This reward model is trained on top of the model which was pre-trained. Okay, your pre-trained model is trained as a reward model on the preference data which is obtained here, which is used to sample and reject data which is not good, and those acts as the instruction tuning data for your SFT model training, where they also have some synthetic data. And then finally your DPO model is ready, and those model will generate input prompts and output again, which will be again sampled. This is a loop procedure which they have followed, but now we are going to see everything in detail. First, what is the procedure? Okay, the SFT training is followed by DPO on preference data, which we saw now. The first one being reward model training. Okay, for data, what they did was they have used a mix of human annotated and AI generated data. Before the process of SFT and DPO, like I said, reward model is trained on human annotated preference data. Here they have used special headers and termination tokens for new capabilities like tool use and multi-message chat protocol and all. Okay, so what is this last line? Because first 3 lines, I guess you would understand explicitly as it is specified there, but what is the last line all about? Those are just technical terms. To say it on a simpler term, it is like a designated start and end token for tool use and multi-message chat protocol. Okay, for example, tool start, tool end, something like that. Okay, those kind of tokens have been explicitly used in the training, it seems. So now the first step is reward modeling. In reward modeling, the training goal is the same as how it will be usually. Okay, it is to reduce the loss, but here the margin term which is present in the loss function is removed. Okay, the reward model is used for rejection sampling. Rejection sampling is nothing but rejecting some samples from training. That is rejection sampling, as simple as that. On human annotated prompts, where around 10 to 30 outputs are chosen. So how these outputs are obtained? It is with the help of the previous model which is already there, the DPO model which I showed you before, right? Or let's say current timestamp is t. The best model till t minus 1 will be used to generate 10 to 30 outputs, and the reward model will 10 to 30 outputs are chosen, so around 50 to 100 even, and then 10 to 30 will be chosen out of it. Okay, so the preference ranking will have 2 to 3 responses. Okay, with the rankings as edited, chosen and rejected, because again the emphasis is on data very clearly here, because when you get an output from LLM, it is not always true that it will give the correct answer, and one impartially correct answer and one completely wrong answer, it is going to say impartially correct answer as true, right? So for that, they have also added human in the pipeline, where they will also edit and provide a sample which they feel is correct, and the model will then reward it. Usually the edited will be better than chosen, then will be rejected because it is decided by human, but there might be cases where chosen is better than edited as well. Okay, the edited indicates that the sample is edited in the iterations of the training. Yes, because like I said, it is a loop of training. Okay, it is not just a single step. Now for the second step, which is SFT, where the SFT model is trained on the rejection sample data combined with the real data and synthetic data. The training started with a learning rate of 1e minus 5, and it has been trained for around 8.5k to 9k steps. You might think, okay, this much only. They would have kept a batch size of around 1000 samples or something like that, even more. Okay, and yeah, the most important thing here is the prompt tokens are masked for efficient loss calculation. Finally, a person has done that, or at least has told out in the public that they have done that. You see, when the loss is calculated, right, it is calculated for the whole sequence. Okay, but you are providing an input already, right? There is no need for the LLMs to calculate a loss for the input because it is just going to complete from the input, right? So here what happens is the loss calculation will be happening only for the tokens which is generated by the LLM, because when you calculate for the input as well, the loss will be always less. But when you don't calculate for the input as input also, then the loss will be high. So the back propagation will be more efficient. Okay, because the penalization should be correct in nature, right? That is why. Okay. So here, for an example, a formatted prompt is considered, okay, for QA, where the LLM is supposed to generate an answer for given a question if there a context as well. And here from answer is to, it needs to complete. Okay, so here what you'll do is we'll ask all the tokens before answer is to, and after answer is to only we'll start the calculation of loss. Okay, that is what is this step all about. Now for the next step, where now your data will be, or your model will be aligned to instructions a bit, but the responses might not be in the favor of your preference. So for that only there is this preference alignment step, which is direct preference optimization, where they have trained it on preference data collected by best performing models from the previous alignment rounds, where the learning rate is again same here, and the beta value they have used is 0.1. And here the special header tokens and termination tokens, which I specified in the previous slide, is masked to stabilize the training. Okay, so that is a very important step here. And then they have used an NLL loss, okay, with a scaling coefficient of 0.2 for the chosen sequence. So basically the preference alignment, if you see, it is a procedure for you to tipping up the scales of log probabilities towards the chosen response and reducing the log probabilities of rejected response. That is how on an overview DPO is. If you want to know in detail, I have already covered a video on DPO. You can just check it out. Okay. Now what happens is this loop will run again and again, and finally you will get the model. But they were not happy with just the text model. They are the best text open source model right now, but they're not just happy with that. They want to beat Gemini, your GPT-4o mini, or GPT-4 or GPT-4o, whatever it is. That is why they started with the vision model. And there are some surprises. Like I said, there are some surprises. Wait for it. Okay. So for training, they have used image text and video text pairs as data for training the image encoder. Okay, they have trained the image encoder from scratch. They are not making a VLM by using pre-trained vision encoder and the LLM they train. They are also pre-training the image encoder. Okay, and they have created an annealing dataset. Annealing, it is a different concept. On an overview, from what I understand, it is you training on a data with very, very low learning rate for the model to have an idea about out of domain images. For example, I have trained it only with nature images, and I can train it with document images with very less samples, so that it will also see, okay, this kind of data is also available. Okay, so that is what is annealing to my understanding. But if you see what is about annealing, you can let me know in the comment section, and probably I'll make a separate video or a shorts on annealing. Okay, Annealing datasets are created by resampling the image caption pairs to 350 million examples by using n-grams. So they have trained it with totally 500 million examples. So the rest of the 150 million examples are collected by using visual grounding, screenshot parsing, QA pair datasets, synthetic captions, synthetically generated images from charts, tables, questions, equations, your maths, whatever it is, which is represented with latex or markdown. Okay, so they have covered all bases to say as an overview, because you have your screenshots, you have your synthetic data, you have document data, you have math. So everything is covered. I hope that is more than enough. The model architecture is where you have the surprise. I guess you would have noticed by now. If not, wait. Okay, it consists of three components, which is an image encoder, image adapter, and a video adapter. Image adapter and video adapters are nothing but your projection networks. Okay, so the image encoder is a VIT/H4 variant, which is a 630 million param model, which has been trained on 2.5 billion image text pair. Okay, so they are training this model for 5 epochs, with the image size being 224 cross 224 and patch size being 16. So patch size is like your tokenizer. Okay, so there you split it at, for example, space. Okay, white space. Here you split it for every 16 pixel, 16 cross 16 pixel. Okay, so that is your patch size. And here they have involved multi-layer feature extraction from previous layer, and it has been injected, or all this information it has obtained from those layers has been injected to the final layer, so that it will have a lot of information which is localized and it is fine-grained as well. Okay, so the image encoder has around 40 blocks with 8 gated attention layers. Okay, so that is your image encoder, and the image adapter is where the fun begins. They have used a group query attention with a cross attention layer. That is fine, but see the parameters. I'm seriously confused. Maybe I would have read wrong. I'm not sure. Okay, if I'm read wrong, I'll also confirm again. But the image adapter alone, they have said they have trained it for 100 billion. Probably this might be combined with the 405 billion parameter variant, and they have trained it in 2 stages. But still, 100 billion. That is really funny to hear, actually. Okay, and for video adapter, they have used a temporal aggregator to sample it over time and retain some time information as well. Okay, for pre-training, they have started with pre-trained text model and vision encoder weights, it seems, and the vision encoder, they have trained it again. Okay, the text vision encoder is unfrozen and the text is frozen. It is trained for 6 billion image text pairs with a batch size of 16,384. Even my context length can't be 16,384, but Mark Zuckerberg has all the GPUs in the world, and he can keep even one batch size. At some point of time, he might, I guess. For learning rate scheduler, they are using cosine LR scheduler, and the learning rate is 10e-4 with the weight decay being 0.0. Okay. For video, they have started from image pre-train and then alleled weights, and the video aggregator is trained from scratch when everything is frozen. The post-training is almost as same as the text. They are following DPO, the loop procedure, everything is followed. For datasets, they have mostly used academic datasets, human annotated and synthetic data. For quality tuning, they have selected utmost high quality data and they have trained it as a separate step finally. Okay, so again, they are not just happy with vision, they also needed to go for another domain, which is speech. Okay, so for this, they have trained it for 15 million hours of multilingual speech data for pre-training. And the automatic speech recognition training data contains around 230k hours manually being transcribed. Wow. And the speech recording spans for around 34 languages, so it supports around 34 languages. Okay. The automatic speech translation data has 90k hours of translation back and forth, okay, across 33 languages. And then synthetic data of around 25k hours. And the model architecture, I'm not too good with it because audio I haven't explored a lot, but from what I understand, they have used a speech encoder and speech adapter. That is fine. Speech encoder, they have used a conformer model. Conformer model is a convolution used transformer model, which is usually a common architecture used when you create a transformer model for audio. Okay, and the input is an 80-dimensional MEL spectrogram. MEL spectrogram, it's like it will generate an audio wave kind of an image or coordinates, which will be sent to your conformer encoder. Okay, the speech adapter is around 100 million parameters, which is composed of a convolution layer, a rotary transformer layer, and a linear layer finally, which is your projection layer. That's all. Okay, for the pre-training, they have used unlabeled data, and the best RQ algorithm has been used for the speech encoder. A 32 frame mask is applied for the input MEL spectrogram. They have used multi softmax loss for masked frames. The features are said to be quantized for stacking 4 frames. 4 frames is like, when I'm speaking, right, this is running it around maybe 40 fps or 30 fps. In that, first 4 frames will be quantized together. Okay, that is what is frame. Okay, and it is being projected at a 16-dimensional space, and they have used a neural network search with a codebook of 8192 vectors. The encoder is trained for 500k steps with the batch size of 2048 utterances. Utterances is nothing but your sequence but in audio. Okay, the supervised fine-tuning integrates the adapter with the pre-training encoder, along with the language model, where the LLM is frozen and the other two are trained. Finally, we have come to the end, which is conclusion. Is the paper good? Yes. Too good. Really? I think this is one of the best paper I have seen ever, because I've felt this happy when I was reading Mistral research paper. After that, I think I'm happy here because a lot of training secrets have been revealed here. But still, what can be improved? I'm being too selfish, but they can release the data name at least. Not the data, at least the data name. Not just, like the custom data. If they have used some open source data, they have said they have used human annotated and synthetic data, they can release some things. Okay, at least as a sample so that we can generate something like that. But other than that, too good a paper. That was nitpicking. Okay, I need to say some negative feedback because no paper is perfect. There is some flaw in paper, and this paper has this one. Okay, and if you want to see the paper, here is the Llama 3 herd of models. Okay, here you can see it is a very good paper, a very good read, and here you can see they are the state-of-the-art model in almost everything. Okay, no one even comes close to tool calling and all. Okay, and that too, like, this is open source. That is the fun part here. And the things which I was saying here, I've took some important things alone, but there might be some other information, but if you want, you can go through those. Okay, and here is the training infrastructure, whatever they did for training this with that scale. Okay, so those information are provided here, and then here is the post-training procedure which they have followed, and then here is the number of turns per dialogue and the average tokens in prompt which are present. Okay, so this will help you to create your data. You can say at general English you want at least 1000 tokens per sample that as your context length, something like that. Okay, and yeah, so this is the paper. Like I said, it will take very long time for going through this paper. It is a very good read though, I'll say that for sure. And here you can see it is too good in benchmarks. Okay, the range in which the LLMs have grown from the last year, it has been too good and shocking to see actually. So yeah guys, this is what I feel is about Llama 3. Lots of secrets have been revealed, and even to be very honest, I haven't said a lot. For example, Llama Guard is something I haven't said about. They have given some emphasis to responsible AI. But yeah, you can go through this paper, or if you want, let me know. We can have a live where we can go through this paper in live, because me going through 92 papers and as a recording, I don't think you'll be able to see. I think you will all sleep actually. Okay, so yeah guys, I hope you like this video. If you like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon. I'll see you all in the next video. Until then, cheers. Having trouble to solve a complex use case? Do you want to know how to fine-tune a state-of-the-art model for your custom use case? Then this video is for you, where I'm going to show you all how you can fine-tune Llama 3 for your custom use case, and we'll see how you can export it as a GGUF format so that you can use it with Ollama or any other CPP libraries which is based on Llama CPP. With that being said, let's start with the video. So for this, I'm gonna use Unsloth, okay? And this notebook can be run on Google Colab. So for that, we are installing pip install Unsloth Colab new at the Git repository. And here, without any dependencies, because each library will have their own dependencies, and we don't want that to happen, okay? Because sometimes dependencies might cost us errors, okay? So here we are going to use Xformers as well as TRL. TRL is your Transformer Reinforcement Learning Library, which will provide you with SFT trainer, DPO trainer, and so on and so forth. So basically, it is very good for training, okay? And PEFT for parameter efficient fine tuning, that is its full form, and it is used for training it with LoRa. Accelerate for efficient GPU consumption while training, and bits and bytes for quantized training, okay? So these are the packages to be installed, and once you run that, the next thing you need to do is, and before going deep, in Google Colab you'll have an option of key at the left, okay? Here at the left you will have a key here, not here in your Google Colab. If you click that, it will give an option for you to add a secret key. All you need to do is just create a token, HF token, and add it as capital HF underscore token with a name, and your value to be your token which you get from your Hugging Face, okay? Only when you do that, these processes will be, you'll be able to do all of these steps, okay? Before going into fine tuning, why fine tuning? That is very important because this model is too good. But see, it is not always you'll be able to do your custom use case directly with the model. For example, math is a very hard use case, okay? And here I'm trying to fine tune Llama 3 with math dataset, okay? So what dataset I'm using, we'll see that later, okay? But we are fine tuning it to become literally a human calculator or NLM calculator. I think human calculator sounds nice, better. Okay, fun part aside. So here we are using Unsloth. So from Unsloth, you are going to use first language model. So this is like your auto model for causal LM, okay? It is a wrapper around that where the training is made around 2 to 3x more efficient with the help of this wrapper, okay? So first language model is imported and your torch is also imported, okay? The sequence length in which the training happens is 2048 tokens per sample, and the D type is none. By default, the D type is used, which is flow32, and then load in 4-bit is set to true so that the model is quantized. Because when you're training, when you're using LoRa, your model's original weights are going to be used only for forward and not for backward, okay? These models are too good to work for forward passes. Forward pass is nothing but your inference, okay? And these models are too good for inferences, okay? So forward pass technically happens in 4-bit, but your LoRa adapters are still at 32-bit, which means your model is being trained in 32 bits or even 16 bits if you're training it in 16 bits. 32 or 16 is good, okay? And here they have the getPef model function, which will technically take your config, LoRa config. So the fast language model has a function called getPef model where you need to provide your model wrapper to be wrapped with adapters, okay? So the model is here. The rank is 16. And if you want to know more about how LoRa works, let me know. Already there is a video on it, but if you want, we can also make a new short video, YouTube shorts. Here the target modules are all the modules technically: Q projection, K projection, V projection, O projection, get projection, up projection, down projection, okay? So technically the names are query, key, value, the output, so that they can concatenate the multi-head, up and down, and gate. Gate is like up and down is your feed forward being projected up and projected down, and once you do a down projection, it is also very important to learn the information there. So for that, a gate projection, okay? So yeah, next you have your LoRa alpha. Alpha is a hyperparameter with LoRa, and it is also 16 here. Dropout is 0, bias is none. Gradient checkpointing is set to Unsloth. It is a parameter which will help you to train faster, okay? random state is 0. Do I want to use RS LoRa? No. So none or false. Loft Q config is none, because when you do loft Q config, the training will happen for during quantization itself. Like your loft Aurora adapters also will be quantized. Okay. Now with LLMs, you can provide a single prompt as input, right? So for this, I'm gonna use this data set, Orca math word problems. Okay. And this is how the dataset will look like. So here is the dataset. See, it is not always that you will get your question like what is 2 plus 2 or what is 5 minus 2. So if I give a hard question, right, so what will happen? It needs to reason it, right? This dataset is one such dataset which will try to enhance that. So for example, when we ask a certain mixture of nuts and nuts consists of 5 parts almonds, 3 parts walnuts, and 2 parts cashews by weight. If there are 672 pounds of mixture, what is the number of pounds of each type in the mixture? So technically what it needs to do, so to find the number of pounds of each type of nut in the mixture, we first need to determine the total number of parts in the mixture. So it is going to be 10. Okay, so it is 672 pounds, so each part is going to be 67.2, and then it can multiply with 67.2. Even technically it could have did it with 672 divided by 5, 672 divided by 3, and it would have worked, but it did at another step as well. Okay, why I'm referring it as it, because this is a synthetic data. Okay, this is not a human annotated data, this is a synthetic data, and the results of this was pretty good. Okay, so you can trust me to use this. So that data set is used here, but as you could have seen there, we had 2 columns, question and answer. But as you all might know now, you can't use 2 columns, right? You need only 1 column. So what can you do there, right? So as usual, we are going to do prompting. Okay, so formatting prompt is very important. Before formatting, make sure that your tokenizer is a EOS token is set. Okay, and those EOS token needs to be added at the end of the text prompt which you are formatting. Okay, because if you don't do that, it will be continuously generating, so on and on. So we are mapping a function, formatting prompts function, which is here, where we are taking the question and answer, and these question and answer are formatted here. Okay, so question will go here, answer will go here, because that is the order in which it is available here. And finally we'll add the EOS token, and that will provide an input text. Okay, and these text will be added to the text which is finally written. Okay, why it is in plural here? It is in plural here because for a reason, because it is set by batch to true. That's why it is going with a loop. Okay, I hope you get that. So now your data set is ready. Now what? You need to go for training. Okay, now you might think, okay, Vasan, training is started, still why this much long notebook? Yes, you have some things in here to discuss. Okay, so for training, you need your training arguments which are provided here, where the training batch size is 2, the gradient accumulation steps is 4, where what happens is your back propagation happens only after 4 steps is completed. Okay, until then forward propagation will happen and gradient will be accumulated together. That is why it is gradient accumulation steps. With very high gradient accumulation steps, you might get a performance degradation, but 4 or 8 is very normal, and that is used when you train it for very large number of data. Okay, the warm-up steps is set to 5. The first 5 steps are warm-up steps where the weights will be first randomly initialized, but when you do warm-up steps, right, it will be more aligned towards the data set in which you train. So if you have large number of data, you can keep more number of steps as well. The max steps I'm training with for 60 was 60, but yeah, the training which I did was complete. Okay, but you can do for 60 steps as well. The learning rate is 2e minus 4. You can see if bfloat 16 is supported. If it is supported, then you can train it in bfloat 16. If not, in fp16. Both are half precision, and the logging steps is 1, where in each steps the log will be printed. And the optimizer user is the AdamW 8-bit optimizer, an optimizer created for models being trained while quantized. Okay, still our model is quantized, only the adapters are not quantized. Okay, and the weight decay used here is 0.01. The learning rate scheduler is linear learning rate scheduler, the seed or random state. Here it is 3407. Where do I want to save the model? The model output directory is math llama3, and I want to push it under the same name as well, math llama3. Okay, that is my training argument. And the trainer not only expects training arguments, it also requires some other parameters which we are going to discuss here. Okay, first is your model. The model is already ready. You have made it as getPef model, which is here. Yeah, when you call the getPef model, a model is attached with LoRa adapters. Okay, that model is ready. Tokenizer, a tokenizer with EOS token set is ready, and your training dataset, you have already mapped your dataset with the formatting and all. So dataset is ready, and you have used the column name as text here. So that is should be provided here as dataset text field. And as you can see here, you are not doing tokenization because the SFT trainer does the tokenization by itself. Okay, and the max sequence length is 2048, which we previously defined at the start, and the dataset num processes is 2. Packing is set to false because you don't want to join sequences together. It will just, what it will do, like it will add separated tokens, and then all of the 5 sequences or 10 sequences will be trained together, something like that. And finally, your trainer is ready. You'll call the train function. Okay, and those stats will be available in trainer stats. Okay, the sample in which it is trained for is 1000, and the steps in which it is trained for is 60, just 60 steps, and it was giving pretty good answers for 60 steps. Here you can see at each step it started in 0.88 and it ended up with 0.47, 44 at times and all, and I'm happy with that. Okay, so now your model is ready, but it is very important that you need to do one thing. Okay, once you get this model right, please do one thing, which is upload your model without LoRa adapters as well. Just what you need to do is just do call an auto model for causal LM of your model, which will just take your model, just push it to a hub itself. For example, here I did it as no LoRa, because if it is with LoRa, it will not be able to, you will not be able to call it with this one. Okay, so please do that. So here you can see I'm calling the model and tokenizer with fast language model.from pretrain with my repository Vasan/math llama3 no LoRa, where I'm setting the max sequence length as 2048. I need to inference in FP16, so flow 16 is set, and I want to do a quantized inference. So load in 4-bit also is set to true. And once you use this model without LoRa is when you'll be able to make a GGUF model. Okay, so what you need to do is I'll write it here. From pef import auto pef model for causal LM model equal to autopef model for causal LM dot from pretrain your model directory, which is Vasant/math Llama3. Just call model dot merge and unload, and then model dot push to hub with your directory here. Vasant. Here you need not provide that. Math Llama3 no LoRa. If it requires, I guess it might require. Okay, your user ID. It just wasn't here. That's all. You need to do this step, and then only you can run the step. Okay, so once you do these two, you can export it as GGUF. There are lots of quantization methods: Q4KS, Q4KM, Q80, Q70, and so on and so forth. You can use any method. Q4KM is a very common method, so I've used that. But don't worry, you can use any method. Okay, here you can see the push to hub merged is already there. That also you can use. Okay, instead, if you don't want to do like this, right, you can also do it like this one. Model.push to hub Vasant/math Llama3 tokenizer along with the model is pushed, where the same method is 16-bit. Okay, which means the model will be merged in original weights. You can also say combined with quantized weights as well, but that is not recommended. So GGF model is pushed and your token is also pushed. It will take some time, okay, when you do that. And what I did was I used that model for inference when I gave this question. Okay, I have 2 apples, my father gave me 2. How many do I have? Okay, so it said you have 2 apples, your father gave you 2 more. So now initial 2 apples plus 2 apples from your father, you have 4 apples. Okay, and when I even did streaming, right, I got the same answer. Okay, the same one. So like I said, you can also call it as autopef model for causal LM before, but once you merged it, it is not required. Okay, so that is how you train and inference your model. But it is not just that. You can also use this model with Ollama, and you will be seeing that in the next video, where I'll be using this model in Ollama, where I'm going to export this model in Ollama with, like this custom model in Ollama by writing our own model file, and then we'll use it with Ollama, because this is the ultimate reveal. We are not just going to stop with this. This is a series where we are going to learn how to generate data, how to use it with Ollama. We are going to build a chatbot, not just Streamlit chatbot. No, it will look like a real chatbot. Okay, so yeah, lots of interesting stuffs coming up. I hope you all like this video, and I hope you all like the series of videos which is coming up for you. I'll see you on the next video. Until then, cheers. Have you ever wondered that how can I use my own custom fine-tuned model with the help of Ollama? Because in Ollama models, there are lots of models in the hub like Llama 3.1, 5.3, Mistral, Gemma 2, your Vision LM models like Lava, Nano Lava, 5.3 Vision, and so on and so forth. But what if I wanted to use a custom fine-tuned model where I fine-tune the model? Okay, have you thought that? So if you have thought that, then this video is for you, because in this video we are gonna export our own custom fine-tuned model with the help of Ollama. Okay, so before going into deep, let me first tell you about Ollama and why you should use Ollama, and then we'll move on with how you can export your custom model and what is the procedure for that. Okay, so to say short about Ollama is a LLM inference engine where it has C++ bindings to it, a Python bindings to C++ inference which is written. And you all know that Python is a very slow programming language, okay, while running. And just imagine this, we are getting the best out of both worlds. Okay, you are inferencing it at C++ and you're writing the code with Python. That is what you get with libraries like Ollama. Okay, still the speed won't be as same as the native speed of running it in C++, because these are bindings, so the call should happen from Python to C++. Those times are, like together it will take some extra time, but still this will be faster than normal Python inference. So that is why you need to use Ollama. It is faster and it supports quantized model inference. That is a very good thing, and it uses or adopts GGUF format, which is a universal quantization format. That is also a very good advantage. Okay, and Ollama is very user friendly. That is probably the best advantage of Ollama. So how to use that? All you need to do is just click the download button. Okay, that is all you need. Be it Mac OS, Linux, or Windows Preview, just click download button and it will give you option Windows, Linux, Mac OS. If it is Mac OS, you can just click Mac OS. For Linux, you can use this command. Okay, any distribution, Debian, or like specified variant like Parrot, Ubuntu, whatever it is, you can use this command itself. For Windows, you have an installer file already. Okay, but it requires Windows 10 or more. You can't use it with normal. Okay, and Ollama, it's also very good because it is a desktop app. It will also provide update notification. Okay, those all will be provided. Now if you are wondering what are the models which is available by default in Ollama, it literally has almost any model: Qwen2, Mistral Large, Mistral Nemo, Gemma 2, Llama 3.1, Deep Sea Coder V2, Mistral, Mixtral, Code Gemma 5.3, Command R. Command R is a model which was released from Cohere. Okay, it is a very good model for tool calling. Okay, Lava, it is a vision language model. Okay, so literally everything will be there, but you are not happy with this. Okay, you have tuned a model, you have made a lot of effort to it, but you want to use that model. So what you need to do for that, that is what we are going to see now. So before going into this video, I want you to make sure that you have watched the fine-tune Llama 3 video, because there I would have custom fine-tuned a model and exported it to GGUF and pushed it to Hugging Face itself. So if you haven't watched the video, please watch it, because that is a prerequisite for this video, because that is the model which we are going to use here. But if you are like not into fine tuning, you just want to see how to export a custom model, you can just download my model itself and then follow the same procedure which I'm going to show in this video. So this is the model which I'm going to use. This is a Llama 3, which is Llama 3.1 to be precise, which is custom fine-tuned for math datasets. And here you can see Unsloth Q4KM GGUF. This is the model you want to use. So two files are very important. One is this one, another one is config.json. Config.json has just the model type. Okay, this is Llama architecture, so that. Okay, other than that, the model file itself is very important. These two are the most important files, and all you need to do is just download it. Okay, you can just click the download button and it will download, and similar it goes for config.json as well. Okay, but if you are like you want to custom fine tune, make sure that you custom fine tune it and export it in GGUF format with the help of Unsloth, like I specified in the previous video. If you want, the link is in the description. So I hope you would have downloaded the model as well as your configuration. Okay, now you need to create a file known as model file. Okay, just do new file and then just type it as model file. Okay, and in the model file I want you all to paste all of these content. Okay, these content I'm gonna provide you as well, and here you need to replace this alone, okay, with the path of your GGF model path. Okay, that's all. And once that is done, just open your terminal and then go to the path in which it is present, and all you need to do is just write this command. Okay, Ollama create, make sure that first it is installed. Okay, let me make the terminal bigger. So how to check that? If you run Ollama and if you get this kind of a screen, then it means it is running. Okay, all you need to do is just run Ollama create a new model or a new file based on the model file which is here, and the model name is tutorial. You can name whatever you want. Okay, tutorial math llama 3. If I run this, what it will do is, based on all of these parameters, this file or this model file will be converted into a model which is supported in Ollama. Here you can see the model data is being transferring, and it will take some time. Okay, so depending on your computation capability, it will take some time, but yeah, it is easy to do. Okay, but what if you want to test the model? That is what we are going to see now. Before that, here you can see for me, I've already exported this model, so it is saying using existed layer and all, but for you it will export the model. Okay, so yeah, with that said, now let's write a script for testing the export. Okay, so for initial testing, all you can do is Ollama run, write the model name tutorial math Llama3. If you run this, it will start running your model, but it will take some time for me because I'm recording. So when I ask, I have 3 brothers and my sister has 4 brothers and 2 cousins. This is one of the most complicated question. Okay, so let me ask, how many cousins do I have? It is very simple if it thinks correctly. How many siblings do I have? It just needs to say 4. Here, this confuses actually the model. That's why I gave this, and this was expected. But when I give things like I have 2 pens, one I gave to my friend, another to mom, one to my dad. How many do I have? Okay, I was expecting 0 minus 1. But yeah, I guess it is okay. For a quantized model, it is doing good, and soon we'll make this model as a chatbot, like using this file. Okay, I'll see you all in the next video where we'll build a chatbot, and then finally we'll build a UI for the chatbot as well. Until then, cheers. If you haven't liked the video, please hit the like button, please share it with your friends, and if you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon. I'll see you all in the next video. Until then, cheers. Are you struggling with finding a dataset that suits your use case? Or are you stuck with the problem of not having a dataset for you to fine tune with? Then this video is for you. In this video, I'm going to show you all how you can create your own dataset, be it for instruction tuning or preference alignment with the help of Llama 3, so that you can fine tune any models like Llama 3 or Phi 3 or any other models, even Quen 2, or even encoder decoder models like T5 with the help of this specific code generated dataset. Let's start with the video now. Before going into deep, there have been a lot of requests to me that you wanted to see this specific content in Google Colab Notebook itself, because there are lots of people who are not having enough resources, so they wanted to see how to do this in Google Colab. So here is your tutorial, which is in Google Colab, so that the notebook is already available in description. You can just upload it in Google Colab and then use it from there right away. For this, we are going to use Grok, where in this video I'm going to show you how you can create your own instruction tuning dataset and also a preference dataset. Both of these will be used for your fine tuning later if you want. Okay, now let's start with instruction tuning. For this, you need two installations. One is Grok and the another one is datasets. Because to upload any dataset to Hugging Face or load anything from Hugging Face, datasets is your library because it is the library which connects to the Hugging Face hub of datasets module. And Grok is the one which will help you to connect with Grok API, in which we are going to run Llama 3 70 billion or 8 billion upon our choice. Okay, so let's start with the instruction tuning dataset first. So how do we generate a instruction tuning dataset? There are lots of ways. The first way would be for you to use few short prompts, where what you can do is you can just give 5 to 10 examples of what kind of dataset you want and say, like, this is the dataset and this is the topic I'm aiming for, and then generate from there. Okay, but what is the disadvantage and advantage there? The disadvantage would be that it is not diverse in nature, but the advantage would be that if it is a use case which doesn't require a diverse dataset, then it can be followed. Okay, so that is the advantage there. But what if you don't have any prior examples to start with? That is when you'll use this use case. Okay, you see, at any topic you can generate n number of questions, right? So here the process is that first what you will do is you will generate some topics. Okay, not some topics, subtopics for a given topic. So let's write that here. So your subtopics is ready, and what you can do is from there, for each subtopic you can generate n questions. So what is the advantage here in this process? You see, when you generate subtopics and move from there, right, you tend to cover more wider area rather than generating it directly from topic, and also you can get more data rather than just using topic. So let's start with that. We are going to start with this approach. So first you need to import OS, and then from Grok we are importing Grok, which will help us connect to our client. Okay, and then you have datasets related imports, which is your dataset dictionary, which is a dataset dictionary object, that's all. Okay, and then load dataset, which is to load dataset whenever you need at the later half. Okay, and then you have import JSON to load JSON and use JSON, or even save it as JSON. All JSON related function will be handled with the help of JSON library. Now what I'm doing is I'm having a topic known as machine learning. I want to generate data for machine learning, and I'm going to focus on 4 different subtopics. Okay, I don't know what are those. I want the model to generate those 4 subtopics, and then for each subtopic I need 10 questions, which means I'm expecting 40 questions from the LLM. Okay, but if I give it directly, it won't be that efficient. So what we are going to do is we are going to do it step by step like it is specified here. Okay, so given a topic, the first step would be to generate list of subtopics. Okay, so the first thing you need to do is subtopic generation. Given a topic, I need you to generate a list of n subtopics. N subtopics is already filled here. Okay, list of, let's say, 4 subtopics that are related to the topic with topics as key. Okay, that is very important because that is how you'll be able to process it later. Okay, and then your topic is there, because what if you are running it in a loop with multiple topic, and for multiple topic subtopics will be generated. In that case, it should be extensible. Okay, and then here you have your topic being provided, and here we are saying, okay, no, like the list must be without numbers, because that is when you'll be able to write a post-processing function which will be able to get the list of subtopics. Okay, so we are saying, like, we need not have any description of the subtopics and all. I don't need any numbers, just separate those with comma. There must be none other than text in the list. Okay, because with list, if you go for a list object, right, it is a very problematic one. We want it as a how can I say, a string with separation of comma. Okay, comma separated string, or you can say it as CSV values, comma separated. Okay, that is what we are expecting as output, and we are saying return a JSON object with a list of subtopics separated by comma and a space. Okay, that is how it is separated here, where the key being your topic and subtopics are generated here. Okay, so that is your task prompt. But what is gonna happen really? Okay, when you call generate subtopics function, this goes into this function where you will provide your topic and subtopics here, and you are calling Llama 3.1 70 billion versatile, which is the latest state of the art model, where you are providing your input. Okay, your input is nothing but your formatted prompt for subtopic generation, where the temperature as 0 and 1024 as max token length. And here you need to make sure one thing: the type should be JSON object, and also make sure that JSON is a word which is available in your prompt, because it is expected by Grok for you to have a format like that. Okay, when you expect a JSON output, you need to add the name as JSON inside your prompt. That is why it is formatted like this. So here you'll have your response. But when you generate responses, right, this is how the output will be: ID, your choices, and many other metadata and all. But here we are looking onto choices. In there we are getting the message and the content of the message. Out of the message we are just taking the content of the message. Okay, here you can see message, chat completion message, and then its content. Because there are some other things as well, like is it a role of assistant or user, is there a function call, is there a tool call? We don't need those and all. We need just the content. So the content is obtained from. Now what we'll do is we'll make a list of these values. Okay, response json dot values. Response json is nothing but this one. Okay, this is a response json, where what we are doing is we are just going to take this as a list, a single value. Okay, this will be a single list, and after that we'll just separate it with the comma, and now you'll have your topics. Even if you want, you can just add a comma and a space here, so that this redundant space which is there here, it won't. Okay, so that is upon your choice. And now you have your subtopics. Now what is the next thing? You need to generate questions, and then you need to generate answers. Okay, generate QA pass, that is your next step. Okay, let's add that as well. I didn't add that, I guess. N answers for question generated, that also needs to be done, because that is when you will be able to format it, right? So for question generation it will be a bit harder than it was before. Okay, I faced a lot of issues at start, and finally it worked. Okay, so here also the prompt is going to be same. Given a topic, I need to generate n questions that could be asked of that topic. Your response should be a list format, and so on and so forth, the same. Okay, make sure that this is there. Okay, there must be no other text than the list number and this bracket. Okay, that is very important there. So here what you'll do is you will again use the same things. Okay, you will provide your subtopics and n questions, and your response is obtained. But we are not focused on that. We are focused on the question generator. Okay, so question generator, what it will do is it will provide the client, which is nothing but your Grok LLM, which you already created as client here. Okay, this client, which is passed as parameter. Along with that, what subtopic and how many questions you want, because there might be n subtopics, but you need to loop through those n subtopics, right? So for that you have a separate function as question generator, in which you will provide your topic or subtopic here with the number of questions you need to generate, and that will becomes your tasks. Okay, and tasks are nothing but your question list, where you need to process those. Okay, so question lists are now provided to question are okay. Sorry, the question list is named as tasks because if you see whatever task you have, right, when you have a question, that is going to become your task, be it answering the question or doing it as a task. So now we should consider the question to be our instruction, so it is tasks there. But even if it was directly question list, it is the same, right? Okay, so now you are getting all the list of questions. Okay, and you'll now go through all of those. Okay, so here if you see, if I call print responses dot choices of 0 dot message dot content, which is the same as here, you will get a dictionary again. Okay, questions, and here you have all the questions like the same, separated by comma and a space. And when I do the same as split, and then here also you can use this, you will get a question list, which is 10 at each list, and then it will all be combined together as a single list. Okay, that is why it is all questions dot extend. Extend is nothing but a method which will help you to combine two question lists, or two list, not just question list. So finally you'll have 40 questions because 4 subtopics and 10 questions each, and here you can see the length of subtopics is 40. Okay, now you need to generate an answer for this, and this is probably the most easiest part. Okay, given a question, I need you to generate an answer which is less than 100 words, because I'm not gonna generate a huge answer. And also considering question generation is the harder part, answer generation is not. Okay, so for that what I did was, okay, to reduce cost, I have added 8 billion rather than the 70 billion which was there before. Okay, and when you send via 8 billion, what you will do is, in the response generator, you'll have all your questions, right? 40 questions. You loop through for each question, and your answer will be generated by the LLM, which you will add it as a response list. And the response list is nothing but your answer list here. So what you will do is, you'll take the content of those, and that becomes your answer. Now you have an answer list. Here you can see these are the answers. Okay, and you also have your question list, which is your all questions. Okay, and when now what you do is, you'll go through all of those and you'll add it into a list as JSON, or a dictionary if you want to put that way, where it will be looking like this. Okay, a question: what is supervised learning? Supervised learning is a machine learning where an algorithm is trained on labeled data to learn a mapping between inputs and outputs. The algorithm is shown examples of input data and their corresponding or correct outputs, allowing it to learn pattern and relationships in data, and it's an awesome response. Okay, so what you can do is, now you can write this as a JSON file, or you can make it as a dataset from list, providing your QA flag list. And you need to create a dataset dictionary object, because datasets are usually requiring a dictionary object. So what you can do is, you can provide as train is to your dataset, and you can push it to hub. For example, I have put it as /synthetic llama datagen, and now I'll show you the dataset on how it looks. Now here you can see there is dataset which has 40 rows. It is a very less dataset, right? Here you can see what are some common supervised learning algorithms. Some of the common supervised learning algorithms include linear regression, logistic regression, support vector machine, k nearest neighbor, and it is a very good dataset which I generated completely with the help of Llama 3, and now it is available in Hugging Face as well. Okay, so that is how you can create your own instruction tuning dataset. But have we stopped in here itself? No, like I said, when you're going for a real-time thing in your office and all, right, it is not always that you find all you need. Okay, it is not just instruction tuning which you'll have. You'll also have some other requirements, which is DPO. Okay, for DPO there are not a lot of very good data sets, so I again created a DPO dataset. Basically here I used Squad. Okay, for Squad I generated a preference dataset, and here you can see the context is here, and there is the chosen answer, and here is the rejected answer. Okay, now I'm going to show you all how you can generate this kind of a dataset in the help of Llama 3 itself, again in the same Google Colab notebook. Let's go into preference dataset creation with the help of Llama 3. And by the way, I didn't use anything like Argilla or human annotation. This is completely AI generated. Okay, so for this, again you have another list of cells here. Okay, so let me close this instruction tuning dataset cells, and here you have your preference dataset. For preference dataset, you are gonna need some imports, which I'm gonna show now. So for this, you need Hugging Face token as well as Grok API. Previously, it was just Grok API, but here you need Hugging Face token as well. Why? You see, when I generated the instruction tuning dataset, it was just to show you all how you can create, but with just 40 I didn't want to demonstrate. I just wanted to demonstrate with a dataset which is commonly used by people, so that's why Squad v2 is chosen. Okay, and here in this I'm just taking the first 100. Okay, I'm selecting the first 100 and then I'm gonna use from there. Okay, so that is why it is here. And here you have load.env and find.env. This is when you use it in local. Okay, but when you use it in Google Colab, it is gonna be your value which you provided here. You need to provide your API key here. All right, you can use .env only when you do it in your local. All right, now you have load dataset function which will load the dataset, and here I'm gonna take the train split alone, in which I'm taking the first 100 values and then I'm making it as a dictionary so that I can run through the dictionary. Okay, so here the number of dataset rows are printed. Here I'm first creating a client for Grok. So by default, it will just use the API which is set it up with the environment here. But if not, what you can do is you can just add it as here. Okay, just copy this and provide your value, for example Grok. Okay, and then put the value here. Okay, so similarly would be the case for you with Hugging Face token as well. This is a method which you will use when you use Google Colab notebook. Okay, now here your client is created, and here what I'm gonna do is I'm gonna just create empty data for chosen and rejected. Okay, so you can see a list of empty string. Okay, and it is to the length of JSON data. All right, so those are empty strings which you can fill, or else you can go for a separate dictionary, write everything there and then save that. That is also good, but it was done in this way because all the original data is also retained. But when you go for a new dictionary, it is harder to save all the data. It is a lot of hectic work. That is why this thing is done, but this is not the efficient way. Okay, now what we are doing is we are going through every data there. First we are getting the context and then the question and then the answer as well. Okay, and here we are just taking the first answer if the answer exists, and if there is no answer, we'll just say there is no answer. Okay, now whatever answer we are considering in the data set, it is the rejected answer, because this is just to show okay, this is defaultly rejected. But what you can do is, if you want, you can just try to add one thing, which is a reviewer. Okay, what you can do is, instead of rejecting it here directly, you can do the same. Okay, format your input as context and question, and here what you can do is rewrite the output to be concise and clear, ensures the response is professional, and as a full sentence, just respond only the answer. This will just provide your answer. Okay, that is all. You can say how you require the answer, because see, usually DPO is not to provide new knowledge, it is about adapting the way it generates the response. Here we need a sentence level response rather than just a phrase. Okay, so here we are asking that, and the response is generated from here. Okay, and what you can do is, if you are defaultly considering this as rejected, then it is fine. If you feel that your data is not good and you want to replace that, then it is fine. But if you feel okay, this might be good and this might be good at some times, what you can do is just add a reviewer agent here. What it will do is, it will take two answers and say like A or B is better. Based on that, you can choose A is your chosen answer and B is your rejected answer, or vice versa, and then replace it here. Okay, because by default here I just said the response is gonna be my chosen answer, and the answer which is available in the data set is my rejected answer. But you can get that in a reviewer LLM which you add there in the pipeline as well. Okay, so final data is obtained from this JSON data. Okay, and it is written in a file known as preference dataset.json. What you can do is, you can just load it as dataset and then push it to the hub. Okay, so that is squad demo preference dataset which I already showed. Okay, so that is how you can generate a dataset on your own, and that too for free. Okay, but if you want to see me building a platform like this so that you guys can just experiment with it, and in live you can generate data for your own, let me know. We'll build a platform where we can generate data on whatever we want. Okay, so yeah guys, I hope you all like this video. If you all like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon. I'll see you all in the next video. Until then, cheers. Hello everyone. In this video, we are gonna see how to build a custom chatbot demo website for any custom LLM you created. I already showed a fine tuning of Llama 3 with the help of math dataset, and that model is gonna be inferred now in this chatbot. Also here I'm gonna try to use multi-agent concepts involved, where if there is a math question, then the math model which I fine-tune will be used, and if there is a general question, a default Llama 3 will be used. For this, the default Llama 3 will be executing in Grok API, and for math Llama 3, we are gonna run it in Ollama, where I already showed how to export your model to Ollama. If you haven't watched that, please watch that and then continue this video so that you'll be able to follow what I'm saying. So let's jump into the video right now. This website is built with the help of a recent framework which is launched to create HTML websites, HTML, CSS, the normal website with the help of Python itself, and that framework is FastHTML. It is not a stable framework yet, but the chatbot was amazing to see in a different way because I was bored of Streamlit, to be very honest. So I thought, okay, let me try to go for fast HTML so that I'll be able to check if my bot is working correctly instead of Streamlit. This gives a different UI. Let's start with the coding now, and then we'll see the demo of chatbot. First, let's try to build a working chatbot, and then we'll try to add the UI to it. Okay, that is how I worked, and it was an easy process to do in that way. So let me show you in that way itself. Okay, so for chatbot, like I said, I'm gonna use Ollama for the math model and ChatGrok for the general model. Okay, so those two are there. Other than those, I have base model imported from LangChain Core Pydantic so that I'll be able to get a structured output, because I would need a structured output in one place, which I'll say later, and then a field which is required to show the description of the type of data I want. Okay, from utils I'm importing math execution and general execution, which we'll see as we go down the line into the code. And then you have OS imported for OS functions and .env to load and find .env. So first we are finding the .env and loading it, where I'm taking the Grok API and setting it as an environment variable, because like I said, I'm gonna need a math model. But not just that. At the start of the video itself, I said we are gonna build a multi-agent chatbot, right? If it is a math question, my math model should execute, and if it is general question, a model which is running in Grok API, which is the general model, should execute, right? You see, this is how the real use cases work. It is not always possible for you to cover every scenarios, and that is where your routing comes into the picture. Here I have created a question router, where based on the question, your path in which you need to execute to find the answer to the question will be found. Okay, so why do I mean by path? Because I already created pipelines of math model and general model separately, which is math exec and general exec, and here the question router LLM will choose whether it should go for math exec or general exec. Okay, basically how is done that? It is going to try to find the type of the question, whether it is a math question or a general question. Alright, so once it finds that, it will be able to route it to the appropriate function. Because if I'm going to give a math question to a general model, right, it is more likely you get a better answer via the math model. But yes, we didn't train it extensively, so there should not be a lot of difference between math and general, but I was able to identify a bit difference. Okay, so here first I'm creating a question router LLM with ChatGrok, and the model name is Llama 3.1 8B instant. And the question router is a question router LLM with the structured output of type question type. Okay, basically it will return a question type which is either going to be math or general. Alright, and then the math model is from Ollama, where I'm going to use math Llama 3 latest, and the general model is Llama 3.1 8B instant, and that is from Grok. Alright, so these are the models which we are going to use in the pipeline. So let's see how the pipeline works. So for this we are going to use a chat history. Okay, by default in chat history it will start with I'm an assistant created by Neural Hacks with Vasan to help you out in general and math questions. Okay, so here we are using a while loop so that the chatbot will be continuously executing. Okay, question is equal to input, here just asking you the question, and we are formatting the question with saying like identify the type of question, whether it is math or general, so that we can send it to the question router and it will say whether it is a math question or general question, and then you can use your appropriate model. Okay, so you're getting the question type by invoking the question router. Okay, and we are getting the output, which is question type alone. Okay, so once that is done, you will get a chat history, which is nothing but a chat history with the chat answer also inside that, where you will call the chatbot with the question type, chat history, and your question. Okay, now let's see the chatbot, where we are just seeing here, no, like question type, if it is math, I'll go for math execution, and if it is general, I'll go for general execution. Okay, for both question and chat history are provided, that is common. All right, I hope you get that. And here, since I don't want to create instances of the model again and again, math model and general model are provided as parameters rather than being instantiated there. Okay, so now what you're going to do is we are going to see about the utils. Okay, so if you go for math execution, which is the first one, first we'll parse the chat history, okay, via the chat history parser function, which is here. Okay, I'm just opening a empty class known as chats, and we are going through the chat history. Okay, and if it is a user conversation, we'll say user is to and the conversation, and if it is assistant, then assistant is to the conversation. And here finally we are combining all the chats with /n, so it will be like user and the next line assistant, and then another line user and another line assistant, like that. Okay, so finally a single string will be obtained from here, which we are providing it here. Okay, for example, both will almost have the same thing. Okay, you are an assistant created by Neural Hacks 2000. Here are your previous conversation. Solve this math question for the user. Your question is also provided, and the assistant will try to answer. Here also you can see I used /n. Okay. Now what we're doing is we are just taking the question formatted with this template. Okay, math template.format, chat history formatted is equal to chat history formatted, which we passed via the chat history parser, and the question is also provided. Finally, you invoke your math model, which is nothing but the custom model we created already. And if you have even watched the video of me fine-tuning Llama 3 for a custom data set on a custom use case, please check it out, because from there only this model is obtained, and I've exported it to Ollama. That is also a separate video. All the links are available in the description. And we are calling that model by invoking with the formatted question, and this answer will be appended to the current chats list, which is just an empty list with assistant as the role, and the question is the user role. Okay, now you have a list of the current chat. Let's say this is chat history is like t-1 till t-n. Okay, till n times, and from t you need to add all of those. So what we are doing is we are just putting this also in another list, and this list is combined with this list of chat history, and it is returned. Okay, so that is how even general execution works. So here you can see a similar kind of thing goes, except that here you will not call dot content, here you will call dot content. Okay, that is due to Grok API, because Grok API tends to give some metadata as well, so you need to just call the content alone. Other than that, everything remains the same, and here the only thing is here I'm just saying answer the question instead of answer the math question or solve the math question. Okay, so those are your utils. And finally what it will do is you'll give you a chat history, but the answer is in chat history of -1 of content, because chat history will just see the structure once now and you'll be able to understand it. Here you can see content, right? If you see, first I'm appending the user and then I'm appending the content. Okay, so the content is nothing but your answer. So chat history of -1, which is this list, is the content, or this dictionary. From there we are getting the content. Okay, just give me a minute. That is how we get the answer, and we'll just print the answer. Okay, so let's try to execute this alone. Okay, so let's start with running this specific chatbot, python for chatbot.py. Okay, actually when I tested once, right, the router wasn't that great, but it was doing a good job. For example, let's try to check our model. Okay, what is 3 to the power of 3. So it should say 27. Here you can see it is saying math model, and here you can see it is 27. 3 to the power of 5. And this model is now running in my local computer. Okay. So you can see here it is saying 3 into 3 9, 9 into 3 27, 27 into 3 81, 81 into 3 240. Okay. That is awesome. So if I ask some general question like, here you can see it shows using math model. Okay. But when I ask, who are you? It says like, I'm an assistant created by Neural Hacks with Vasan to help you out in general math question. For this it used general model. Okay. So it is working. But when it didn't work was when I give a problematic statement like, I have 3 apples. My father gave me one. He gave my sister. How many do I have? If I do this, it will use the general model for some reason. Okay. I'm not able to run it with, this model, but it was working actually still. You have 5 apples, your father gave you 1, so you have 4. You gave 5, but you only have 4, so you didn't have any apples left. That is what it was trying to say. This is also, partly good. But if we want, right, what we can do is to check this. What I'm gonna do is by default, I'm gonna run this one. Okay, question type equal to math. I'm just overriding it here, and when I run the same question, we need to see if there is a better answer or even a worst answer. I'm happy with both of those because that shows I'm fine-tuning it, right? So I'm just trying to say, yeah, see, you can see, right, the difference, when I fine-tune. -1. Since it is a negative number, that means you don't have any more apples left, and it is saying like, you have 0 apples only. That is why I said like, if I can, fine-tune for routing also, it would be better. Or even for router, I can use a better model like, a 70 billion model, and that would be even better, I guess. Probably, but I'm not sure. Yeah, 70p is versatile. Yeah, guys, actually, the agent is technically working because here you can see this agent uses 2 LLMs. One is math, another one is, yeah, now it's working. Awesome. Now it is going for math model. And yeah, we'll get an answer. We know that. So the math model is also working, the general model is also working, now the router is also working, which isn't practical. See here, this is also good. If you are looking at a logical answer without any, you would still be left with -1 apple, which isn't practical. I like it, like the way it said that. So yeah, I love this agent. So now we can say that the agent is working, but we need to, combine this as a chatbot. We'll see how we can do that now. So with minor changes, I have this file known as chatbot backend. So previously I was testing it with 8 billion, so I'll change the router to 70 billion. Okay, so the same things are here. Okay, but I'm not running this loop. Here what I'm doing is I'm just calling chat. Okay, and the chat history will be a parameter where I'll just get the question, because initially I'll append the question to chat history, and that will be the -1. Okay, and once I get the answer, I'll put it in the content of chat history later, which will be the answer. Okay, it's the same thing, all are same like before, but what we are going to do is we are going to change the front end. The front end will be a bit confusing because if you don't have some experience with HTML, this will be a bit hard. Okay, so from FastHTML.com and everything is imported, where I'll be using D-Link, Picolink and all. Okay, and word streaming HDR is set to true. So I think it's Wisconsin or something like that. It was saying something like that. I'm not sure of what it is actually. Okay, but here you can see the T-Link is your Tailwind CSS file link, or that URL which will be loaded, and D-Link is your style sheet link, and Picolink is default. Okay, so here you can see this is how the chat message will be rendered. Okay, so there is, how can I put it, a default way of execution which is already written with some class names. Okay, so if I write as chat bubble primary, it will give me that violet color or blue color, however it was. And if it is assistant, which will keep it as assistant, the condition won't match, it will come secondary, then it will give pink. Okay, and chat class is nothing but like to render the chat again. Okay, this is chat content and chat bubble, that's all. Okay, so chat, here you can see end or start, whether it is starting or ending. Why it is that? because if user, it will be like ending the conversation, and if it is assistant, it will be like starting the conversation. So technically that is just to put it whether left or right. Usually if you see user content will be left and assistant content will be right, sorry, opposite, user at right and assistant at left. So that is why it is start and end. This is div is nothing but the division tag which is there in HTML as well, where we are keeping a chat header division here, where I'll be passing the role. Along with, inside that, I'm creating another division tag where I'll be providing the content with the ID name as chat content, whatever it is here, and chat bubble as well. Okay, so this will be done for all the chat. So these, what it will do is it will just create a chat bubble. That is what happens here. And to get the chat input, the text box, that is what is here. Input, and type is equal to text, name is equal to message, ID is message input, type of message is the placeholder where I can enter my questions. And here you can see classes input border w width is full. Okay, so input border is nothing but the line which you saw for the text box or around it. Okay, these are just classes which will be rendered with the help of Tailwind. Okay, so these are default classes, so you should not change the value and all. Okay, now the page where like a chatbot demo is what is the heading, where I'll be displaying the chat message and I'll be getting the input we already said shown here. And if I click the button, where the button is primary button, that is what happens with the page. Okay, now it is like you are running an async process inside the page. That is why we are keeping it as two separate functions, where this will take a message as input and also a send command. Okay, so here what you are doing is we are appending it in the chat history, which is nothing but messages here. Messages is your chat history, and await is like waiting with an asynchronous process where you will be sending your message to the chat message, and those will be displayed first, right? Because if it is not an empty chat history, it will be displaying right continuously. That is why like we are using async processes, because if you don't use async processes, it will be reloading again and again. And then what we're doing is we are checking if there is an input, and if there is an input, the chat function which we already saw as chatbot backend will be run, and that will be a stream output, and that is added to the chat history again. Okay, and again that is also displayed. Okay, so finally you'll run this as an application as chatbot frontend is to app. So is to app is common, but chatbot frontend is based on the file name, and I'm gonna run it in port 8000 with reload set to true, so that if I make a changes here, it will be affecting there as well. Okay, so if I run this, it will be just python chatbot frontend.py. Now if you see, it will run and it will say like 127:0:1. Yeah, it is available there, and now we are going to see that. Okay, but right away I just said the wrong name. I was just even thinking I was saying wrong. WS means WebSocket. Okay, and WSCon means WebSocket connection. Now you can see, right, the chatbot is there, and here you can see there is a border, type a message as placeholder, the send button is also there. And if I ask a question like this, let's see the logs as well. The logs will be printed as usual. Okay, because I'm adding the print statements here. You can see a math model is being used. Let's go to the UI again. So it's now thinking, and here you can see, okay, it is saying the answer correctly, which means I don't have something like that. And if I give some simple question as well, like what is 2 + 2, it is still using the math model, and the answer is sudden. Okay, and here you can see, if I ask how many did my father gave, it will be able to retain the chat history, right? So it will be able to answer my question as well. Your father gave you 2 apples. And if I ask some general questions like what is Olympics, it will also answer that, because like I said, we are using both models, right, as an agent. Here you can see the Olympics is a global sporting event, and so on and so forth. So yeah guys, I'm the first probably to make a chatbot with the help of FastHTML and show it as a video in YouTube. So yeah, if you like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, hit the bell icon. I'll see you all in another video. Until then, cheers.